Hello, everybody. This is Mr. McNair. Sorry, this is Mr. McNair, and this is a video on adding and subtracting polynomials. Okay, one thing that I want to kind of remind you about adding and subtracting polynomials is that pretty much all you're doing is combining like terms. And like terms is pretty much when you're adding things that are alike. For example, if I have 4 apples, and then I want to add together with that 2 apples, how many total apples do I have? Well, that's 6 apples. Notice that 4 apples plus 2 apples isn't something like 6 apples squared. All right, 4 apples plus 2 apples is just 6 apples. The term is the apples, so terms don't change when you add like terms. Also, let's say you had 4 apples and you wanted to add to it 2 oranges. Well, what's 4 apples plus 2 oranges? Well, it's just 4 apples and 2 oranges. It's not like you could combine them and make them 6 oranges. No, it's going to be 4 apples and 2 oranges. You can only add like terms. Okay, so just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, you combine like terms, like we just said. Like here in example 1, I have 12p cubed plus 11p squared plus 8p cubed. Now, what are the like terms here? Well, 12p cubed is like terms with 8p cubed. Remember, for things to be like terms, they have to be the same variable with the same exponent. So 12p cubed plus 8p cubed, that's a total of 20p cubed. Remember, when you add like terms, like the like terms here are p cubes, the terms don't change. And then we're just going to drop down this 11p squared. Now, can you add 20p cubed plus 11p squared? No. Why not? Because they are not like terms. Remember, same variable, same exponent. Okay, let's look at example B here. So in example B, the first term that we're going to deal with is this 5x squared. Is there anything like terms with that? No, so we're just going to write that down. So here's 5x squared. So we're done with that. I'll just cross that out. Then we have our negative 3x. Anything like terms with negative 3x? No, so we're just going to write that down. All right, and then lastly, we have a negative 6 and a positive 8. What's negative 6 plus 8? Well, that's going to be positive 2. And those are done. Okay, all we did is add like terms. Now, in 5x squared minus 3x plus 2, is there anything in there that are like terms? No. Okay, once again, for them to be like terms, they have to be same variable with the same exponent. Okay, moving on. Example 2. Here we're going to find the sum of the polynomial and we're going to write it in standard form. This is actually, even though it might look a little complicated, this really isn't that bad because all you're doing is adding the like terms. Okay, so let's start off with our highest exponent since we're putting it in standard form. Highest exponent that we have up here in part A is a 3. Anything is like terms with 5x cubed? Well, this negative x cubed is. What's 5x cubed plus negative x cubed? Well, that's going to be 4x cubed. So we're done with those. Let's cross those out so we know that we don't have to add them again. Next, we're going to go with the x squareds. So we have a positive 2x squared, we have a positive 3x squared, and we have a positive 4x squared. So 2 plus 3 is 5. 5 plus 4 is 9. So that's going to be a positive 9x squared. So we're done with those now. Let's go down to the x's. All right, the x's, we have a negative x. And then we have a negative 4x. Negative x plus negative 4x is negative 5x. Remember, when you add like terms, the terms don't change. Okay, so those are done. And then lastly, we have our constants. We have a positive 7 here, we have a positive 7 here, and we have a negative 8 here. 7 plus 7, that's 14. 14 minus 8, that is positive 6. So, and there we go. We added all the like terms. That's all that you're doing there. Let's try part B. Part B, you're doing the same concept. Highest exponent that we have there is an exponent of 2. So we're going to add all of our x squares together. 2x squared plus positive x squared. That gives us a total of 3x squared. So those are done. Then we have our x terms. We have a positive x, and we have again another positive x. X plus x is 2x. Remember, when you add like terms, the terms don't what? They don't change. All right, and then lastly, we have our constants. We have a negative 5 and a positive 6. Negative 5 plus 6 is positive 1. And those are done. And there you go. All right, let's move on. Now, I do want to remind you before we get into the subtraction of polynomials that when you have a subtraction problem, subtraction is the same thing as adding the opposite. So something like 7 minus 3, that's the same thing as writing 7 plus negative 3, right? Because subtraction is the same thing as adding the opposite. In here, in the first term, or the first part of the expression, we have 7 minus 3. We have a positive 7 is the first term, and a negative 3 is the next term. Same thing down here, positive 7 and negative 3. Now, that helps us out in problems when we're subtracting polynomials, because here we know that this is a subtraction problem. And that subtraction sign belongs to this whole polynomial. So what we need to do is take that subtraction sign and distribute it into the polynomial. Okay, so we're just going to rewrite this first polynomial. Negative 2x to the third plus 5x squared minus x plus 8. And now we're going to distribute the negative to the right side here. A negative and a negative, that combines to be a positive. So that's positive 2x cubed. And then negative 3x. And then positive 4. You could have also thought of this as distributing a negative 1 into the parentheses. Negative 1 times negative 2x cubed is positive 2x cubed. Negative 1 times positive 3x is negative 3x. Negative 1 times negative 4 is positive 4. All that good stuff. All right, now that you've distributed your negative, we're right back to what we did in example 2, just combine like terms. So let's start with our highest exponent. Negative 2x to the third, and then positive 2x to the third. Well, those cancel out because that adds up to 0, so those are gone. Next, we have our positive 5x squared, and that's not like terms with anything else, so we're just going to write that down. That's gone. Next, we'll deal with our x. We have a negative x and a negative 3x. That combines to be negative 4x. Remember, when you add like terms, the terms don't change. And then lastly, we have a positive 8 and a positive 4. 8 plus 4 is 12. And those are gone. And there we go. All right, same thing down here in part B. We're going to take this negative sign and distribute it into the second polynomial, because that minus sign belongs to everything. The first polynomial, again, we're just going to write it down. And then if you distribute that minus sign, that will become minus 2x squared plus x plus 4. And then we're going to go ahead and combine like terms. 3x squared and a negative 2x squared, that combines to just be 1x squared. And remember, when you add like terms, terms don't change. All right, negative 5x and a positive x, that's going to be a negative 4x. And then lastly, positive 3 and positive 4, that's positive 7. All right, great. And there we are. Those are our two answers. Okay, let's move on. Let's try one more. Perform the given operation. Now, some of the problems, addition and subtraction, will be mixed all in the same section. So you just have to pay attention to the operation that goes on between the polynomials. This first one we know is an addition problem because there's an addition sign between them. The second one we know is a subtraction problem because there's a subtraction sign in between the two polynomials. So the first one, all we're going to be doing is adding like terms. So let's add the like terms here. 1/2 a squared plus 3/2 a squared. Well, 1/2 plus 3/2, that's 4/2, or just 2. So that's 2a squared. Next, we have b, a positive b, and a negative 4b combined to be negative 3b. So those are gone. And then lastly, we have a positive 2 and a positive 5, which adds to a positive 7. And there is our final answer. All right, part B, that's a subtraction problem. So we're going to make sure that we take that minus sign and distribute it into the second polynomial. We're just going to drop down this first polynomial, negative 10x squared minus 3x plus 7, and then with the distribution of the negative, we would have minus x squared and a positive 9. Now let's combine like terms. Negative 10x squared combines with negative x squared, which adds up to negative 11x squared. So those are gone. Next, we have our negative 3x. Well, that's the only thing that has an x solely for the variable, so that's gone. And then we have our positive 7, our constants, positive 7 and positive 9, which add up to positive 16. And then those are gone. And lo and behold, here's our final answer. All right, great. I hope this video has been helpful to you, and have an awesome day.